Okay, today we're going to talk about compositions. Basically, what compositions are, it is either combining equations or actually doing a substitution from one equation into another. Different ways you can do compositions. First off, you have the addition function, which basically if you have two functions added together on the inside, you can separate it out by addition. The second one is subtraction, where we have f minus g of x will create f of x minus g of x. If you have fg, this means multiplication of function f and g together. You're going to multiply function f times function g. And the same thing with division. But keep in mind with division, whatever function g is cannot be equal to 0 because we can't divide by 0. So let's take a look at how this works. We have f of x equals x squared plus 2x and g of x equals 2x plus 1. I'm going to do the f minus x. So when I do this, I end up with x squared plus 2x, those are supposed to be x's, minus, and then I'm going to do parentheses on this last part because I want to make sure my signs change, 2x plus 1. And now I just got to clean it up. Distribute the negative, I get x squared plus 2x minus 2x minus 1. And then when I combine like terms, the 2x and the minus 2x go away, and I'm left with x squared minus 1. So, you try the next one. And what should happen here is when you combine the equations, we have the x squared plus 2x right here. Here's my function f, and over here is my function g. When I add them together, combine like terms. So I'm going to go ahead and let you pause it, and then I'll go back and fill in what you should get for f of g and f divided by g, and you can check your work. Now when I multiply these out, I'm going to go ahead and use the box, and the box will look something like this. When I multiply this out, I get 2x to the third, and then I get 2x times 2x is 4x squared. X squared times 1 gives me x squared, and 2x times 1 is 2x. Combine like terms and I get the following. When I combine like terms, I can combine the 4x squared and the x squared, and I get 5x squared. So fgx is 2x to the third plus 5x squared plus 2x. Now try the next one. Okay, if you did this properly, we have function f up on top of the fraction, and we have 2x plus 1 at the bottom. I would try to factor, see if I can clean anything up, but notice, even if I factor out an x, I don't have anything I can cancel out. So, my final answer is just the x squared plus 2x over 2x plus 1. I put the restriction that x cannot equal negative 1/2 because, remember, g of x cannot equal 0. And when I plug negative 1/2 in for x, that's going to create the bottom to be 0.